Hello, welcome back again to the channel. On this video, we're going to discuss about the convergence of sequences. So let's get started. So first, we're going to discuss the informal definition. What is the meaning that a sequence is converging to a certain number L? So a sequence converges to L if we can make the tail of this sequence eventually as close as we want to L. So that's the informal definition of when a sequence is convergent to a certain number L. So for example, if we have this following sequence, a sub n equals 1 minus 1 over n, and if we list several terms of the sequence, so for example, we have the following, and if we look at the numbers on the sequence, we can see that the number on this sequence is getting closer and closer to 1. So we suspect that this sequence converges to 1. Now, in order to prove that this sequence is indeed converges to 1, we need to show that we can make the tail of this sequence as close as we want to 1. So how can we measure the closeness of this sequence to 1? So the way we measure the closeness is by making a strip around L equals 1. We have a strip that capture L equals 1 inside. So to say that the tail can be made as close as we want to 1, meaning that all the entries of the sequence will eventually be inside this strip, but perhaps starting from a certain n. So for example, if we plot a sub n equals 1 minus 1 over n, so this is the first term here, which is equal to 0, and then this is the second one, the third, the fourth, and so on. And we can see that starting from a sub 11 and so on, all the entries or all the terms of the sequence are all inside this strip. So that is it's the same thing as saying that the tail of the sequence can be made closer to 1 of a distance 0.1, right? But 0.1 is only one of the measurement. In order this sequence to converge to 1, we need to have this kind of property for every strip that can be made around 1. So for example, if we make a very small strip like this sequence will converge to 1 if again eventually the tail of the sequence will get inside this strip for L for all bigger n. So for example, starting from n equals 1 up to n equals 50, we can see that none of the term of the sequence is inside the strip, right? But if we continue further, starting from n equals to 126 at least, we can see that the terms of the sequence are inside of the strip, right? So in order to say that this sequence is convergent to 1, no matter how small our strips are, then the tail of the sequence will eventually trap inside that strip. If it is always true for any size of strip, then the sequence really convergent to its limit, right? So okay, so now we give also the formal definition of when a sequence converges to L. So we say that a sequence a sub n, this should be a sub n, converges to L if for every epsilon positive, so this epsilon is exactly measuring the width of our strip, there is n such that for all n greater or equal to n, this is basically saying the same thing, which means that the tail of the sequence starting from n equals to capital N will lies inside the strip. So all the terms of the sequence will be fall inside or in between L minus epsilon and L plus epsilon, right? So for example, the former sequence 1 minus 1 over n is convergent to 1. Why? Because if we look at the difference between a sub n and 1, so let's compute the difference. Okay, so first, given epsilon positive, take capital N, a natural number such that this capital N is greater than 1 over epsilon. Such n exists. Why? Because remember that the positive integer is unbounded from the right? So if we have a certain point on a number line, then at some point there must be a positive integer bigger than that point. In particular, if we look at 1 over epsilon, that 1 over epsilon will be somewhere on our number line, right? And since the positive integer is unbounded, then at some point there must be a positive integer bigger than this 1 over epsilon. So take that capital N. Now if we look at all positive integers greater or equal to this capital N, we have that the difference between a sub n and 1, so this a sub n is 1 minus 1 over n, so that the difference is exactly 1 over n. Since n is greater or equal to capital N, then 1 over small n is less or equal to 1 over capital of N. But then, since capital of N is greater than 1 over epsilon, then 1 over n is smaller than epsilon. So this says that the difference between the terms of the sequence and 1 is less than epsilon, which is the same thing as saying that a sub n is between 1 plus epsilon and bigger than 1 minus epsilon. Or in terms of the strip, all the terms of the sequence is inside the strip of width plus minus epsilon, right? Okay, so for exercise, you may try the following problem. Explain visually why the following sequence does not converge to any number L. Thank you for watching. See you again on the next video. Goodbye for now.